when light with electric field oscillations in every direction in the plane perpendicular to the plane of oscillations is called unpolarized light. When light with oscillations, that is electric field oscillations only in one plane, then we can call it as polarized light. So when we are passing this unpolarized light through a polarizer, the output will be a polarized light, and that process is known as polarization. Hey all, I am Hari Krishnan from the Department of Physics, Vidhyaashram PU College, the Temple of Excellence, and we were discussing about wave optics. So the last portion in this particular chapter is nothing but polarization. So we discussed what was polarization, and we'll see one small portion of polarization, and this chapter is finished. So let's get on to it. So again, the simple definition for unpolarized light was discussed in the previous session. Again, just to refresh that, we can say that if the electric field oscillations are in every direction or in every plane, for example, there is XY plane, YZ plane, XZ plane, like that, many planes are there. So if the electric field oscillations are in every plane, then we can say that that particular light is unpolarized light. And the natural light sources we see in our everyday life is actually unpolarized light. For example, the light from the sun, the light from the candle, everything is unpolarized light. Even light from a flashlight also is unpolarized most of the cases, unless that is monochromatic. Okay, so again, scientifically we can have a definition for unpolarized light which states that when light with electric field oscillations in every direction in the plane perpendicular to the plane of oscillations is called unpolarized light. For example, we can say that if electric field is vibrating in every possible plane, then we say that, okay, that particular light is unpolarized light. And the process of converting this unpolarized light into polarized light is known as polarization. And it is very simple. It just means that instead of the electric field vector having vibrations in every possible directions, that is in every possible plane, we are restricting that into just one plane, either the XY plane or the YZ plane, just like that. So if we can restrict the vibrations or the oscillations of an electric field vector to a specific plane only, then we can say that that particular light is polarized light. And if it has vibrations or oscillations in every possible plane, that is known as, or multiple plane, we can call them as unpolarized light. So again, what is polarized light? So again, we can say that with a simple definition, when light with oscillations, that is electric field oscillations only in one plane, then we can call it as polarized light. So again, it can be represented as, again, that is, if this is unpolarized light, that is, if this is the direction of propagation, the electric field vibrations will be in all possible planes. For example, like this. In all possible planes, if the electric field is vibrating, then we say that, okay, this is the vector representation of unpolarized light. You can see that electric field is vibrating in all particular directions, and this is the direction of propagation. Always remember, the direction of propagation will always be perpendicular to the plane of the oscillations or vibrations. Now, this is unpolarized light, which means the vibrations are in every possible plane or just simply in multiple planes. So, what if we convert this into a polarized light? Then we can actually say that, okay, electric field vibrations are only in one particular plane like this. The electric field oscillations will only be in one plane, that is the Y and X plane. But sir, this is only the Y axis. Where is the X axis? Again, that is why there is a dot here. The dot signifies, okay, there is an X axis also present there. So again, you can call this as the vector notation or vector representation of unpolarized and polarized light. The arrow signifies the direction of propagation, and the vectors signify the oscillation of the electric field also. So this is one simple way of representing that particular light vector or simply the electric field. And moving on, plane of polarization is the plane perpendicular to the plane of oscillation. That is, the plane of polarization, polarized light will be perpendicular to the plane of the oscillation. And by passing light through certain crystals, we can actually polarize light. That is, there is a problem, right? How can you polarize light? How can you restrict these oscillations only to one particular plane? So that particular problem or obstacle can be dealt with using certain crystals or certain materials. So we can actually polarize unpolarized light, that is the process of polarization, through certain crystals by using certain crystals. For example, those crystals are crystals like tourmaline or certain prisms, or even a Polaroid can be used in order to polarize unpolarized light. So when we are passing this light through a polarizer, that is the object or the instrument which we are using in order to polarize that light is known as a polarizer. So when we are passing this unpolarized light through a polarizer, the output will be a polarized light, and that process is known as polarization. And you can also say that an example for such polarizers are tourmaline and Polaroid. Certain crystals are also there. These are all examples for polarizers. So for example, let's assume that, okay, this is an unpolarized beam of light. So this is unpolarized. This is unpolarized. Now, if this is allowed to pass through a polarizer, that is an object or an instrument which restricts all these oscillations into one plane only, which only allows oscillations in one plane only to pass through them. Imagine it like this. If you are trapped in a jail cell, okay, if you're trapped in a jail cell like this, bars like these, if anybody wants to hand over you anything, let's say a piece of stick, if they are trying to hand it over to you like this, will the stick pass through? No, right? You can't pass a stick horizontally like this. You can only pass the stick vertically inside because the bars will prevent the stick from going in horizontally. Just like that, if this polarizer is present here, it will only allow the vibrations in one particular plane to pass through that. All the other oscillations will be stopped, which means that all the excess oscillations or vibrations in other planes will be negated and only one set of oscillations will be allowed to pass through. For example, this will be moving in like this. Unpolarized light is going to move into the polarizer. So this is a polarizer. And then when it passes through the polarizer, the excess vibrations or simply the unwanted vibrations are negated, and only this polarizer will only allow oscillations, let's say in the vertical plane. So oscillations only in one single plane to pass through them. So only one single plane is allowed to pass through them. So you get the polarized light which is only in one single plane. That is either in the XY plane or the YZ plane. Just like that, you will get oscillations. The unpolarized light is now polarized. So using a polarizer to filter the unpolarized light or convert the unpolarized light into polarized light, that particular process is known as polarization. Now you can make it a step further and improve on this particular design. That is, if you place another polarizer, let's say this is polarizer 1 and this is polarizer 2, or generally this polarizer, the second polarizer is also known as an analyzer. So the second polarizer is also known as an analyzer. So it is also known as an analyzer. Why it is called that, I'll just explain it to you. But before that, just imagine it like this. Now, the unpolarized light is now polarized by passing it through a polarizer. Now, the vibrations are only in one plane. Now, if the second polarizer is also kept the same way as the first polarizer, there is no problem. That is, if this is a jail cell, okay, you can pass a stick vertically through it. You can't pass it horizontally. That much is accepted, right? That is happening here. Now, if I keep one more jail cell behind it, one more jail cell just like this behind this one, then again, if anything is passing vertically through that, there is no problem. It will just pass on right through. There is no problem with that. because they are parallel to each other, which means that, okay, if this is a jail cell, this is another jail cell. Since they are parallel to each other, in between, whatever can go through will go through. But what happens when I start to rotate it? That is, this particular polarizer, which only allows this particular lines, vertical lines to pass through, if I rotate it by an angle of theta, what happens? Then obviously the amount of light that can pass through that second polarizer reduces, which means that the intensity of the light is now being reduced. So you can actually use an analyzer or simply a second polarizer in order to control the light which is getting in or out of a specific area. That is what your sunglasses do. That is what your cooling glasses do. That is what the films in your car windows or like building windows, all of them do. It is very simple. That is, if you're wearing a cooling glass, you might have seen that if you compare it to a sunglass, you can clearly see that, okay, the cooling glass is much more comfortable in a lower light condition, but the sunglasses are more effective in a sunny area. Right, you don't see cricket players wearing Ray-Bans and going into the cricket field, right? They always wear sunglasses because the light is too heavy. But what they do is that they have certain films which is stuck onto the glasses. That's what they take. That is what is making the sunglasses sunglasses. For example, if you're sitting inside a car window, you can actually control the tint of that particular car window. You can control, okay, you can make it more darker or more lighter depending on the type of tint you're using. So all those are basically applications of polarizers, which means that they will first stick a polarizer like this, and behind that they will stick another polarizer, and depending on the angle they are using, the light, the intensity of light is actually controlled. So this is actually an application, or they are exploiting this particular effect and helping you achieve your cool shades and your cool cars and even your cool buildings. So just to refresh, we can say that polarizer is a device which plane polarizes unpolarized light. If you just want it in one sentence, you can say that, okay, polarizer is a device which plane polarizes unpolarized light, which means it is restricting the oscillations in multiple planes into just one singular plane. So that is known as a polarizer, and that is the instrument that is used for that is known as a polarizer, and the process is known as polarization. It's very basic and it is very simple also. Again, the last topic is Malus law. So what exactly is Malus law? Malus law states that the intensity of light is actually proportional to the angle of the analyzer. I just told you that, I just showed you that, okay, if you have a polarizing sheet, you can use an analyzer, and by rotating the analyzer, you can actually control the intensity of light, the brightness or the effect of that light that is coming through in the car windows, in the sunglasses, in the cooling glasses, like that. If you place two cooling glasses together, it is like two polarizers being together, and the effect is doubled. And based on how you rotate it, based on how the angle is between the polarized films, you will get the intensity also accordingly. So again, Malus law just states that, okay, when a beam of light is passed through an analyzer, that is what we just saw earlier, when it is passed through an analyzer, the intensity of the transmitted light varies directly as the square of the cosine of the angle between the pass axis of the polarizer and the analyzer. So again, don't worry about what pass axis is. That is, when you're placing a polarizer like this, there will be a pass axis. Basically just telling you that, okay, in this particular plane, the light can pass through. That is in the xy plane. The pass axis is just in the xy plane. So only light in the xy plane can cross through, or the pass axis is in the other direction. So the light in the other direction can only pass through. It is just there to ensure that, okay, which direction the light is coming through, which way the pass axis will determine, okay, which plane the light is going to be polarized in. So you don't have to worry too much about that. It's just a technical term. So again, what does the law state? So Malus law states that the intensity of this particular beam of light will be directly proportional to the square of cos of the angle between the polarizer and the analyzer. That is, again I told you, this will be a polarizer and this will be the analyzer. So if I rotate this by an angle of theta, the intensity of light will actually vary. Now, how does that intensity vary? It varies as the square of the cosine of the angle between the polarizer, that is the first polarizer, and the second polarizer, or simply the polarizer and the analyzer. So depending on the angle between them, the intensity of the light actually varies. That is known as Malus law, and you can just simply write it using a constant of proportionality, that is I is equal to I naught cos square theta. So this is Malus law. So again, it is very simple. I is equal to I naught cos square theta, which just means that depending on how you place the analyzer and polarizer, the intensity of light will actually vary. And this actually also proves, that is, Malus law actually also proves the transverse nature of light. So light is transverse in nature and not longitudinal. So light is a transverse wave, and that is also proven by Malus law with this particular definition, mathematical proof. Malus law proves the transverse nature of light. You also had Brewster's law and a couple of other laws and Rayleigh scattering law as well, but all of that is now in the deleted portion. You don't have to worry about that. And this is officially the last topic in your wave optics chapter. So I hope you have understood everything about polarized, unpolarized, polarizer, and polarization of light. So again, I'll see you all with a new session, a new chapter. Until then, thank you.